In this lesson, we're looking at what integral really means. And what integral means is area under the curve. Remember, derivative meaning slope. It's just something that is straightforward in calc. Integral meaning area is just as vital. Then what we can do is, if they ask for an integral of a function from a specific point, so from x equals 2 to x equals 5, this is first of all how we're going to write it, the integral with these limits, 2 and 5, of the function. Well, this function is just a line, and what we can do is we can say, well, here's x equals 2, here's x equals 5. The area under the curve is this area right in here. The area between the graph and the x-axis is probably the better way to say it than area under a curve. But what we can do is a lot of times we can get just a basic geometric shape. And right here we have a right triangle. We can find the area of that right triangle. And that's what an integral is. So the area of a triangle is 1/2 base times height. My base is 1, 2, 3 units long. And my height, well, this is the ordered pair 5, 9, so the height is 9. Base of 3, height of 9, which means I have an area of 27 over 2. That is the area, that is the integral of that function. They can give us more complex graphs, something that looks like this. Well, all we have to do for this, from 0 to 10, is we can break it down into various shapes. So here's a trapezoid, here's a half of a circle, and here's what would be a little mini triangle at the end. Well, even this, I don't know the area of a trapezoid, but I could break it up even more into rectangles and triangles. This triangle has a base of 1, a height of 3, so this guy would be 3/2. This guy has a base of 2, a height of 3, so its area is 3. This rectangle is 2 by 3, so it is 6. This triangle here is base of 1, height of 1, so we'll say that's 1/2. And this circle has a diameter of 4, so a radius of 2. So a circle is pi r squared. We only want half a circle though, so divide it by 2. The radius is 2, so that's 4 pi divided by 2, so this part becomes 2 pi. So my areas, I have 3/2 plus 6 plus 3, and then I have the plus 2 pi and the plus 1/2. Now here's the only thing that we need to look at. Being above the axis or below the axis makes a difference. The fact that it's below the axis means that that's a negative area. So I need to subtract 2 pi at that point. And then I can just simplify from here, 10, 11, 12 minus 2 pi ends up being your answer here of how much area we have under the curve. And you can't simplify it more than that. That's an exact answer. Here's another quick example. This might be a good idea to pause the video and see if you can find this area, and then hit play when you're ready to check your answer. Okay, so here's what you got. If you break it up into these two triangles and a rectangle, 1, 2, 3 by 2, so this is 6. These triangles are both base of 1, height of 2, so they're 1 and 1. This triangle over here has a base of 1, 2, 3, 4, a height of also 4. So 4 times 4 is 16, half of that is 8. And this circle has a radius of 3. So it'd be 9 pi for your full circle, but because it's only a half, it'll be 9 pi over 2. So my area, this 6, 1, and 1 is 8, but it's down below, so it should be negative. The 9 pi over 2 is up top, it should be positive. The 8 is above the axis, so it should also be positive. So when you simplify that, 9 pi over 2 is your area under the curve. Well, that's it. For simple areas, eventually we'll get to things that look more like this with parabolic. We don't have regular shapes and how we're going to find areas for them. For the time being, we can use basic geometry and their formulas to find our areas.